Supporting the growth of distributed generation, utilising digital twins and the smart grid. Key findings from the literature review. One of the key findings is the need to have a defined digital twin model. Having a defined model will help the relationships between the different characteristics of the distributed generation digital twin to be fully realised. This in return will allow the digital twin to operate as efficiently as possible. Another key finding is to fully utilise the smart grid technologies. Fully utilising these allow the most accurate data collection possible. Having devices installed at key points in the grid network also allow real-time communication with the digital twin. This is so it can perform as accurately as possible. And then another key finding was the proper management of distributed generation. Typically, distributed generation has no real management in place, typically operating with little to no input from the grid. With the integration of a digital twin, this will allow the system to basically have a cause and effect, responding to conditions as they arise. To date, the Gantt chart summarizes the progress of the project perfectly, with the only change being that data sourcing should be extended. As I found under development, there has been a need for new datasets going forward as the digital twin matures, which means additional datasets may also be required. These additional datasets could include grid load data, household load profiles, and external distributed generation. Here on this slide, we see where we are in terms of the entire project. At this stage, there is still quite a lot that needs to be done in terms of the project. Here is an initial view of what the graphical interface of the digital twin looks like. At this present time, the majority of the data is acting as a placeholder. And going forward, I will need to integrate the Transpower grid exit point data into the digital twin based on the location of the load data from ANSCO. For the distributed generation, I need to calculate a system large enough to provide full satisfaction to the industrial load, and seeing how this affects the rest of the grid. From this, I will need to get some example loads to further diversify the grid, ranging from household loads, electric vehicle charging, and other potential distributed generation systems. Overall, there is still a potential to identify additional characteristics to implement into the digital twin. As development progresses, these will be realized and implemented, offering a comprehensive digital twin to accurately manage and monitor a distributed generation system. The finished project outlook. The main goal is to provide a fully functioning digital twin. This will have the functionality to fully control and act upon uncertain characteristics of the network grid, causing all resources to be fully utilized as efficiently as possible. And the end goal is also potentially open-ended, meaning the project will most likely act as an initial starting point for continued progression in the project order goal. This is all for my project update, and I thank you for your time.